Hi students, this is Shanti ma'am. Today now we are going to discuss about ninth chemistry, atomic structure, unit 11, part 1. Introduction of atomic structure. The atomic models are important, you know that, because they helps us visualize the interior of atoms and molecules and thereby predicting properties of matter. The first discovered, the Greek philosopher Democritus first suggested that all matter is made up of tiny particles. He called atoms. His ideas were rejected, and for 2000 years scientists believed that every substance was made up of earth, fire, air, and water. Modern atomic theory was first put forwarded by John Dalton in 1803. He imaged atoms to be tiny, indivisible particles. In this lesson, you will learn about the structure of the atom. We have learnt Dalton's atomic theory and J.J. Thomson model in class 8th standard. Now, we will learn about subatomic particles and the other atomic models to explain how these particles are arranged with an atom. Discovery of nucleus. In 1911, Lord Rutherford, a scientist from New Zealand, performed his famous experiment of bombarding a thin gold foil with very small positively charged particles called alpha particles. Alpha particles means nothing but helium atom. Helium H2 4. This is alpha particle and highly positively charged particles also. He selected a gold foil because he wanted as thin layer as possible, and gold is the most malleable metal. Malleable means nothing but, you know that already in 8th standard also, we can beaten by thin sheet. We can beaten by thin sheet, that is called malleable. So he observed most of the alpha particles passed straight through the foil. Some alpha particles were slightly deflected from their straight path. Very few alpha particles completely bounced back. He observed from that the nucleus has the positively charged. The most of the alpha particles passed straight through the foil. Through the foil. Some of slightly deflected and very few alpha particles completely reflected to 180 degree. What he find out from the experiment? The gold foil also one of the atom. It has the nucleus also positive charged, the helium also positive charge. The positive definitely will reflected, right? He identify the nucleus inside the atom, right? I upload one video. Okay, from this the Rutherford generalized these results of alpha particles scattering experiment and suggested a model for the atom, that is known as Rutherford atomic model. The Rutherford atomic model, according to this model, the first point, the atom contains large empty space. The atom contains large empty space. Apart from the nucleus and outermost electron, between the place, that is the empty space he identified. The second point, there is a positively charged mass at the center of the atom, known as nucleus. The nucleus has the positively charged and present in the center of the mass. Third point, the size of the nucleus of an atom is very small compared to the size of an atom. The nucleus is very small compared to atom. Atom is big and smaller size in nucleus because the nucleus is present inside the atom. So nucleus is very small in size. The electrons revolve around the nucleus in closed circular paths called orbits. Orbits means the circular path. The electrons revolve around the nucleus. Revolve around the nucleus. That path is called what, students? The orbits. An atom as a whole is electrically neutral. That means the number of protons and electrons in an atom are equal. Always the protons and electrons are equal means definitely that is electrically neutral also. The atom as a whole is electrically neutral. You see, Rutherford model of atom structure is similar to the structure of solar system. Just as in the solar system, the sun is at the center. The sun is at the center and the planets revolve around it. Isn't it? Similarly, in an atom, the nucleus contains the main mass and the electrons revolve around it in orbits or shells. So, Rutherford considered the model of the atom was somewhat like that of the solar system. Is it clear, students? Next, limitations in Rutherford model. Why the Rutherford model was failure? Because according to electromagnetic theory, a moving electron should accelerate and continuously lose energy, which means that according to electromagnetic theory, not normal theory, according to electromagnetic theory, a moving of electron should accelerate. அது சுத்திக்கிட்டே இருந்துச்சுன்னா definitely it will be lost their energy. Due to the loss of energy, path of electron may reduce and finally the electron should fall into the nucleus. Finally, the electrons definitely fall into the nucleus. அது சுத்திக்கிட்டே இருந்துச்சுன்னா அது டயர்டாகி கண்டிப்பாக எங்கே போய் விழுந்துரும்? நியூக்ளியஸில் போய் விழுந்துரும். If it happens so, atom becomes unstable. இந்த மாதிரி இருந்துச்சுன்னா ஆட்டம் வந்து அன்ஸ்டேபிளாக இருக்குது அப்படின்னு அர்த்தம். But we know that atoms are stable. And electrically neutral, right? Thus, Rutherford model failed to explain the stability of an atom. அவரால் ஸ்டெபிலிட்டி ஆஃப் ஆட்டத்தை சொல்ல முடியல. என்ன சொல்ல முடியல அவரால்? the stability of atom, ஆட்டத்தோட ஸ்டேபிளை பற்றி அவரால் சொல்ல முடியல. So this model was failure. After the followed that, the Bohr's model developed. The Bohr model of an atom in 1913, Niels Bohr, a Danish physicist, explained the causes of the stability of the atom in different manner. The main postulates are, in atoms, The electron revolve around the nucleus in stationary path called orbits or shells or energy levels. போர் என்ன சொல்லியிருக்கிறாரு, ஒரு நியூக்ளியஸை சுற்றி ஸ்டேஷ்னரி சர்க்குலர் பாத், அது ஒரு ஸ்ப்ரிங் மாதிரி சுற்றிக்கிட்டே இருந்து நியூக்ளியஸில் விழல, பட் அது எப்படி இருக்குது, ஒரு ஸ்டேஷ்னரி பாத்தில் சுற்றுது. See the picture. They take one orbit in stationary path. It is called orbits or shells or energy levels. Second point, while revolving around the nucleus in an orbit, an electron neither loses nor gains energy. While the revolving around the nucleus, the orbit வந்து எனர்ஜியை லாஸ், எலக்ட்ரான் வந்து எனர்ஜியை லாஸ் பண்ணவும் பண்ணாது, கெயின் பண்ணவும் பண்ணாது. The second point. The third point, an electron in a shell can move to higher or lower energy shell by absorbing or releasing a fixed amount of energy. Higher எனர்ஜியாக இருந்தாலும் லோயர் எனர்ஜியாக இருந்தாலும் எனர்ஜி ஷெல் வந்து எவ்வளோ அமௌண்ட்டாக எனர்ஜி அப்சர்வ் பண்ணுதோ the same energy amount will release. The same energy will be released. So that is fixed energy. The orbits or shells are represented by the letters K, L, M, N or the numbers n equal to 1, 2, 3, 4. ஒரு ஆர்பிட்டுக்கும் நேம் என்ன சொல்லியிருக்காங்க, K ஷெல், L ஷெல், M ஷெல், N ஷெல் அப்படின்னு சொல்லியிருக்காங்க. இல்லைன்னா நம்பரில் n equal to 1, n equal to 2, n equal to 3, n equal to 4 அப்படின்னு நம்பர் கொடுத்துருக்காங்க. K ஷெல்லை மெயின் ஷெல்னு சொல்லுவோம். LMN அதுக்கப்புறம் வர்றதெல்லாம் சக்சஸிவ் ஷெல்ஸ் அப்படின்னு சொல்லுவோம். ஸோ போர் கால்டு தேம் as energy level or energy shells. I upload one video about limitations of Bohr's model. One main limitation was that his model was applicable only to hydrogen and hydrogen-like ions. Example, helium plus, lithium 2 plus, hydrogen has 1 electron, helium plus also 1 electron, because 1 electron removed from that, helium atomic number 2, ஹீலியத்தில் ஒரு எலக்ட்ரான் போயிடுச்சுன்னா அதோடைய பேலன்ஸ் ஒன்று தான் இருக்கும். நெக்ஸ்ட்டு லித்தியத்துக்கு அட்டாமிக் ஸ்ட்ரக்சர் 3, பட் லித்தியம் 2 ப்ளஸ் மீன்ஸ் ஒன்லி 1 எலக்ட்ரான். 3ல் 2 போயிடுச்சுன்னா 2 எலக்ட்ரான் போயிடுச்சுன்னா மீதி ஒரு எலக்ட்ரான் தான் இருக்கும். பெர்லியம் 3 ப்ளஸ் அப்படின்னா பெர்லியத்துக்கு 4, பெர்லியத்தில் 3 எலக்ட்ரான் போயிடுச்சுன்னா பேலன்ஸ் ஒரு எலக்ட்ரான் தான் இருக்கும். ஸோ ஒன்லி 1 எலக்ட்ரான், ஒரு எலக்ட்ரான் இருக்கக்கூடிய ஹைட்ரஜனுக்கும் இல்லை ஹைட்ரஜன் லைக் அயான்ஸ் ஹீலியம் ப்ளஸ் ஆர் லித்தியம் 2 ப்ளஸ் பெர்லியம் 3 ப்ளஸ் இதே போல் உள்ள அயானுக்கு மட்டும்தான் அது அப்ளிகபிள். இட் குட் நாட் பி எக்ஸ்டெண்டட் டு மல்டிபிள் எலக்ட்ரான்ஸ் நியூக்ளியஸ். இஸ் இட் கிளியர் students? I hope all should understand. If you like my videos, please subscribe my channel. Thank you.
Bohr's model of atom. Various models of the atom have been proposed by eminent scientists over the years. These models have increased our understanding of the atomic structure. Among these models, Rutherford suggested that electrons revolve around the nucleus in well-defined orbits, but there was a problem with this. The motion of electrons in Rutherford's model was unstable because any charged particle moving in a circular path emits electromagnetic radiation. Thus, the electrons would lose energy and fall into the nucleus, making the atom highly unstable. Then, which would be a better model of an atom? To overcome the objections against Rutherford's model of atom, Niels Bohr in 1913 proposed a new atom model. What does this model propose? It first proposes that electrons revolve around the nucleus in specific orbits, and these orbits are associated with definite energies and are called shells or energy levels. These orbits or shells are represented by the letters K, L, M, N. The maximum number of electrons that can be accommodated in a particular orbit is 2n to the power of 2, where n is the number of the orbit. Thus, K shell would have 2 electrons, L shell would have 8 electrons, M shell would have 18 electrons, and N shell would have 32 electrons, and so on. That said, what does this model next propose? It next proposes that the maximum number of electrons that can be accommodated in the outermost level is 8. And finally it says that the orbit closest to the nucleus has minimum energy and the orbit farthest has the maximum energy. Well then, does an electron radiate energy by itself? Since electrons move in a particular orbit, they do not radiate energy by themselves. What happens instead is when an atom absorbs energy, the electrons get excited and jump into the next higher energy level. The electron can radiate energy and return to its original state or drop down to the next energy level. Bohr's model works well for simple atoms and is easy to understand. It is one among the atomic structures still in use today, and the other being the quantum mechanical model. Things to remember. In 1913, a Danish physicist Niels Bohr proposed an atomic model known as Bohr's atomic model. In an atom, the electrons revolve around the nucleus in definite energy levels called orbits or shells. The maximum number of electrons that can be accommodated in a particular orbit is 2n to the power of 2. The maximum number of electrons that can be accommodated in the outermost shell is 8. The orbit closest to the nucleus has minimum energy and the orbit farthest has maximum energy. Electrons are excited to the higher energy levels by absorbing energy and return to the lower energy levels by radiating energy.
The nucleus of an atom was first discovered when a beam of positively charged particles emitted from a radioactive source was aimed at a fluorescent screen. The particles caused the fluorescent screen to glow. When a very thin sheet of gold foil was placed in the pathway of the particle beam, a few particles were deflected to the side. Occasionally, particles were deflected straight back. But nearly all particles passed right through the gold foil, as if it were not there. The scientists concluded that atoms must be mostly empty space, and that because some particles are deflected, there must be a small positively charged central mass, which they called the nucleus.